So, hello everyone. Welcome to Q Physics Academy. This is our lecture number 5 of quantum mechanics. Okay, and this lecture is actually based on simple harmonic oscillators. In the previous lectures, we have discussed the what are the lowering operator, what are the raising operators, and as well as the what are the eigenfunctions of ground state, first excited state, and second excited state, respectively. Right. But in today's class, we are discuss some important concept, right? It's important concept. Expectations value of various operators. That is very important for your competitive exam perspective. So, I hope all of you are all of you learn something from my channels. If you learn something, please like and subscribe my channels. Okay. And if you feel any kinds of doubts, then you comment my channels. I definitely give you proper solutions. How can you deal with this type of problems? And what are the basic reasons? What are the basic reasons? I will discuss with you. Okay. This is our lecture number 5. In this lectures, we are discuss some uh, expectations value of operators, right? Some expectations value of operators. Okay, so start our lectures. Uh, let's start our lectures. Expectations value of operators. Let's take a heading. Expectations value of operators. Values of various operators. Okay, expectations value of various operators. This is our lectures. It means we are discuss here mainly expectations value of positions operators and momentum operators. We are mainly discuss here the expectations value of positions operators and momentum operators. Also the uncertainty of position operators, uncertainty of momentum operators, and the product of these two uh, uncertainty, delta x and delta phi for different state of harmonic oscillator. How can I deal with this type of problems? This is very important for your JEST examinations and TIFR examinations. In this, but this part is important for only. I mentions here this part is important for only uh, JEST, TIFR, uh, TIFR, CSIRNET, gate examinations, etc. Okay, and also some higher study part. Okay, so this part is not important. Few it's very simple concept. Also IITJAM, yeah, it is IITJAM perspective. Also IITJAM. So this part is very important for your upcoming exam. Upcoming exam. Okay, so this is very important for your upcoming exam also. Just you uh, focus. All right. So, okay, uh, let's start our lectures. Let's start our lectures. So we already know the lowering operator and raising operators, right? So lowering operators, A cap equals to m omega upon 2h cut, not pi h cut, 2h cut x cap plus I upon root under 2h cut m omega p cap. So this is equation number 1. Okay. Similarly for raising operators, a cap daggers, it is very easy to remember m omega upon 2h cut x cap minus I upon 2h cut m omega p cap. This is equation number 2. So as you try to calculate the expectations value of positions operators and momentum operators, right? So we now express these positions operators and momentum operators in terms of lowering and raising operators. You just notice here equation number 1 and equation number 2, right? Equation number 1 and equation number 2 are expressed in terms of positions and momentum operators, right? We are now performing a reverse process, right? What can I do? We do uh, we do express positions operators and momentum operators in terms of in terms of uh, lowering operators and momentum operators. So it's very easy. Just add and subtract. We get the positions operators in terms of lowering and in terms of raising operators. So first we add these two equations. Add equations 1 and 2. Add equations 1 and 2. So what I get? Actually 2 m omega upon 2h cut x cap equals to a cap dagger. So x cap equals to um, root under 2h cut upon m omega into half into a cap plus a cap daggers. Okay, we just uh, expressed in a very crucial way. So that is equals to h cut upon 2m omega a cap plus a cap dagger. So okay. So now this is equation number 3. It is a very important expressions. It is very important expressions we get. So uh, we get positions operators in terms of lowering and raising operators. This is equation number 3. In a similar way, we express momentum operator in terms of lowering and raising operators also. So what can I do? We subtract equations 1 and 2. Okay, yeah. Subtract equations 1 and 2. And from 1 to 2, actually 1 to 2. So we get 2i upon 2h cut m omega into p cap a cap minus a cap daggers. Okay. So it is equals to I into 2 upon h cut m omega into p cap a cap minus a cap daggers. So p cap equals to, we get minus I root under h cut m omega upon 2 h cut m omega upon 2 a cap minus a cap daggers. So finally, okay, finally we get another beautiful result of momentum operator in terms of lowering and raising operators. So basically, this is equation number 4. Okay, this is equation number 4. So basically, we get two equations, right? One is positions operators in terms of lowering and raising operators. Another is momentum operator in terms of lowering and raising operators. Actually, we get these two results, but don't try to remember these two equations. You just calculate it. Okay, it's a very simple. It's a very simple process, and this is very easy to calculate. This is very easy to calculate the from lowering operator to raising operator to uh, position operator and momentum operator. So it's very easy process. Don't try to remember these two equations, number equation number 3 and equation number 4. You just do yours, do by self. Okay, is do by self. Not try to remember. मगज करने के लिए सोचो मत. ओके. ओके. मगज करने के लिए आपको सोचना ही नहीं है. So this are the two very important concept. Okay, I think you do. I think you understand what can actually what you will try to learn here. Okay, so these two are the very important case uh, we are discuss here. Positions operator in terms of lowering and raising operators, and momentum operators in terms of lowering and raising operators we are discuss here actually. Okay, so okay, our next task is we try to find out the expectations value of positions operator with respect to nth state and expectations value momentum operator with respect to nth state. Okay, okay, let's just take a heading, expectations value of positions operator. Expectations value of positions operators. Okay, so expectations value of positions operators, it means it is equals to n x cap n. Actually try to find out with respect to nth state, right? It's a very easy process. So we are already calculate what is the value of x cap, right? Just put here n brass n x equals to, actually we get h cut upon root under h cut upon no 2m omega. Okay, exactly a cap plus a cap dagger n cap. Okay, we just try to pull out the constant term. So this is equals to h cut upon omega n a cap plus a cap dagger get n. Okay, so this is equals to h cut upon 2m omega. This is equals to n a cap n plus n cap dagger n. So we are now here apply the when lowering operators acting on nth state, we get actually root n minus 1, and raising operators acting on nth state, we get n plus 1 root under n plus 1 and n plus 1 get. Is it right? We get this type of results actually. Okay, we get this type of result. Okay, we just apply here. Okay, so this is equals to h cut upon 2 omega in root n minus 1 plus n root under n plus 1, n plus 1 get. Okay, so we get our finally a beautiful result h cut upon 2m omega root n bra n n minus 1 get plus root under n plus 1 bra n get n plus 1, right? Get n plus 1s. So it is actually represented as like that h cut upon 2m omega 2m omega root n delta chronicle delta n minus 1 plus plus root under n plus 1 chronicle delta n plus 1. We are already know the what is the properties of chronicle delta, right? We already know. So if you know, just I try to refresh it. Okay, so delta m comma n is equals to 0 when m not equals to 0, when and it is equals to 1 when m equals to n. Already we know if two states are equals, if these two states are equal, then we get equals to 1, and if these two states are different, then it's equals to 0. Okay, so this is the way to calculate the expectations value of positions operator for harmonic oscillators for nth state. But if you try to find out the expectations value for ground state, what do you get? Expectations value of x in ground state, expectations value of positions operator for first excited state. We perform these two equations. Okay, okay. So expectations value of x cap with respect to ground state, and what is the physical meaning of this? We are trying to find out, right? We are also try to find out from these mathematical expressions. We try to find out what is the physical meaning, right? What is the physical meanings? We are trying to find out it also. Okay, you just here we just put it down. Okay, it's something that's fine for you also, right? Okay, yeah. Is that clear? So for expectations value of which is about the ground state, right? So we have calculate expectations value of x with respect to ground state. That means this is, so this is equals to h cut upon 2m omega 0 a cap plus a cap dagger 0 get. Okay, so this is equals to h cut upon 10 omega 0 bra 0 a cap get 0 plus bra 0 a cap dagger get 0. Okay, so finally, if we know already we discussed in case in previous lectures, when lowering operators acting on lower state, it gives you 0 value, right? But a raising operators acting on higher state, it gives some value. So what is the value actually? 0 plus 1, it gives you first excited state, right? So this is equals to 0 plus 1 gate. So this is equals to gate 1, 1 into gate 1. So finally we get a result. This is equals to h cut upon 2m omega. This part will give you 0 value, and this is equals to actually 0 plus 0 gate 1. Okay, so these two are different state, right? These two are different state. this is equals to h cut upon 2m omega Harmonic delta 0 comma 1. But these two states are different, so it's obviously it gives you 0. So for ground state, right? So for ground state, expectations value of positions operators is 0 for harmonic oscillators. For ground state, expectations value of harmonic oscillator is 0. Why? Can you know? Why? Because uh, without calculations, without any calculations, this lengthy mathematical form, we are just easily say in physical way, expectations value of positions operator is 0. How can I say? So in physical expressions, right? And now we explain physical expressions. Physical explanations, if we follow the physical explanations for our competitive exam purpose or for your interview purpose, physical explanations. We know the ground state eigenfunctions, right? We know the ground state eigenfunction is a Gaussian form, right? We know the ground state eigenfunctions. This is equals to, sorry, this is equals to m omega upon pi h cut whole to the power 1 by 4 e to the power m omega x square. This is a Gaussian functions, right? And x is equals to minus infinity to plus infinity. X equals to minus infinity to plus infinity. If we plot these wave functions, right? If we plot these wave functions, it already looks like that. This is x equals to 0, x equals to plus infinity, equals to minus infinity. So is this symmetric wave functions? Symmetric wave functions. So if we try to find the expectations value of x, what is the meaning of that? Expectations value of x, right? Expectations value of x means minus infinity to plus infinity psi 0 x psi 0 x into dx, right? But we segregate the integration limit, we segregate the integration limit as like that. Minus infinity to 0 psi 0 star x psi 0 x plus 0 to infinity is dx psi 0 star x into x cap psi 0 x dx. Okay, so we get one positive value, another negative value. It's what is the meaning of that? It means probability of finding the particle, probability of finding the particle for minus infinity to 0 and and 0 to infinity are same. Probability of finding the particle, probability of finding the particle from minus infinity to 0 and 0 to infinity are same. So expectations value gives you 0 value. What is the physical meaning of that? Probability of finding the particle from minus infinity to 0 and 0 to plus infinity, it's same. So what is the physical significance? Probability of finding the particle is equal in both sides of origin, right? Both side of x equals to 0. At x equals to 0, left side probability to find the particle, and x equals to right side probability to find the particle is equal. Okay, I think you clear. So for ground state, we get obviously for ground state for harmonic oscillator, we we get uh, it must give you the probability of finding the particles both are equal same. So that's why the expectations value of x is equals to 0, right? So this is the physical meaning of expectations value with respect to ground state. So expectations value with respect to ground state 0, it means probability of finding the particle are equal both at x equals to 0. I think you will be clear. Okay, I think you will be clear the point. Okay, okay. Next we go to the expectations value for momentum operators. Take a heading. Expectations value of momentum operators. So we already know p cap is equals to minus, okay, minus I root under m omega h cut upon 2 a cap minus a cap dagger. We get the momentum operators, right, in terms of lowering and raising operators. So for ground state, for nth state, expectations value of momentum operator for nth state, so this is equals to n p cap n. So this is equals to, okay, equals to minus I n omega h cut 2 n cap minus a cap dagger get. So this is equals to I m omega h cut upon 2 n bra a cap n cat minus bra n cap dagger get. Okay, so this is equals to I m omega h cut 2. So this is equals to root over n bra n get n minus 1. This is equal to the n plus 1 bra n get n plus 1. So finally you get I into m omega h cut upon 2 into root n Kronecker delta n minus n minus 1 minus root under n plus 1 Kronecker delta comma n plus 1. If these two states are different, then you get obviously 0 value. Okay. 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 So this is your result of expectations value of momentum operators. So I give you a homework. I give you a homework. Find out the expectations value of momentum operator for ground state. And what is the physical significance? And what is the physical significance of this? Okay, you just try to calculate it, post in our comment you post here, or you or okay, sorry. Homework part is actually expectations value of momentum operators for ground state. Okay, and what is the physical significance? What is the physical significance? And what is the physical significance? You just solve it and send the solutions in a comment channel, a comment box. I will check it. Okay. So today's class is very short, I know, but this class is very important for your exam purpose. In the next classes, I definitely take a long video in my holiday and then cover the harmonic oscillator part also. Okay, and obviously we discuss some problems of previous year books. Obviously we do some problems, so don't worry. I take actually to first of all select those questions that are very important, and actually all questions of IITJAM, JEST, TIFR, and CSIRNET gate. All questions are mandatory for the preparations who are preparing for JEST or TIFR or who are preparing for NEET. So IITJAM, GAST, TIFR, every question is very important for the preparation for your examiner for your preparations. You should do for you get a better rank in your examinations. Okay, so don't ignore any of the question paper. You do it, good do it. Otherwise, you not clear the fundamental concept of harmonic oscillator actually. Okay, so today's lecture is very short. I think it's 32 minutes. So you just make a notes in proper way and try to try to itself also. mm, okay, just do one homework. It is useful for your preparations part also. Okay, you all of you do it in proper way and send me the solutions. I just check it. And what is the physical significance? It is very important, right? What is the physical significance? It is very important. We just I know all of you calculate it, but you if you do not understand the physical meaning of this expectations value with respect to ground state, then there is a then you must lack some knowledge. So I think there is no issue, uh, but you definitely do it. Okay, and you do it, you feel proud. Okay, okay. So again, thank you for watching this video, and we meet again in another lecture series. Okay, thank you.